Hey class, I just wanted to repost some review videos for you so you can have something to look back on. You can play it back, you can pause it, you can do whatever you need to do. So say for example, if you wanted to, you and your mom to dress alike, or you and your dad to dress alike, or you and your favorite person. Your outfit and your shoes is the original, and you're going to have to make a copy to fit their size. So you would have to have the correct measurements, all right? So here you see triangle ABC, all right? And then we're going to go ahead and we're going to draw a copy, D, E, F, okay? That's a 5. Okay, so first and foremost, this is the original, and this is the copy. All right. So the question would ask, side AB measures 10, and the same corresponding side DE measures 5. You would ask yourself, what was multiplied by 10 to get us 5? Now, a lot of you will want to divide, but when finding scale copies, we do not divide, we multiply. Now, what we would do was divide this number into that number to find out what was multiplied. Nonetheless, you would only divide this number into that number to find out what number you will multiply. You will not divide all sides, okay? But just to keep it simple, we're going to focus on multiplying only, all right? So you can blatantly see that with this side being 10 and that side being half, you know that 5 is half of 10. So we can honestly say that 10 times 1/2 equals 5. All right. Now remember, what we do to one side, we have to do to all sides. Okay. So 8 times 1/2 equals 4. Okay. BC, side BC, corresponding side EF. You got 4. Okay. Now let's do CA. AC, however you want to do it. 6 times 1/2 will give us 3. All right. So moving from here to here, going this way, we would have to say that the scale factor is 1/2. Now moving from right to left, we simply do the opposite. All right. If the question asked you, starting from the copy, what is the scale factor for side EF to the corresponding side BC? You know you multiply 4 by 2 and you get 8. So all of these sides must also have a scale factor of 2. FD, that side measures 3. You multiply that by 2, you get 6. Same measurement for the same corresponding side. And then DE is the same way. 5 times 2 gives you 10. All right? So moving from this way, the scale factor is 1/2. Moving from this way, the scale factor is 2. What we learned in math in previous years, just to make it a little easier from you, anytime you want to make a whole number into a fraction, you simply put that 2 over 1. And then that's why when we're going the opposite way, we find its reciprocal. The opposite of that is 1/2. All right? So this to that, that to that. Opposites. Remember that. Okay? You just find its reciprocal. All right? Now, also as well, with scale copies, we might as well go ahead and just introduce you to in the video, because we've already discussed this in class. You have side AB. The corresponding side is DE. You have side BC. The corresponding side is EF. You have side CA or AC. The corresponding side is DF. Okay? So what you're going to do, side AB is corresponding to side DE. That symbol means line. Side BC corresponds to EF. We're not going to make this harder than what it is. Side AC corresponds to side DF. Okay? Just that simple. All right? So, turning over, remember your vocabulary: scale drawing, scale factor, scale copy, and reciprocal. What you do to one side in a triangle, you must do to all sides in any shape, object, or anything that's given to you. Okay? What you do to this side, you must do the same thing to all sides. So this was 1/2. This scale factor was 1/2. Okay? 1/2, 1/2, 1/2. All right? Moving from right to left, this scale factor was 2. So you have to multiply that by all sides, and it must give you these measurements. It's just that simple, all right? Now, moving forward, let's use those same, to keep things simpler, let's use those same triangles, same exact triangles. All right, corresponding points. Corresponding points, we already did corresponding sides. Let's do it again. Corresponding side, AB. Corresponding side in the other figure is DE. All right. Corresponding side BC. The corresponding side in the next figure is EF. All right. And this is for every single last object you're given. Corresponding side AC corresponds to side DF in the other figure. All right. Now, we're going to use the same numbers. We're going to use these same numbers. Okay. Now, we have 10 for this side, 8 for this side, and 6 for this side. We have 5 for this side, 4 for this side, and 3 for this side. All right? We can say that side AB is 2 times larger, longer, however you want to say it. But side AB is 2 times longer than side DE. You see it? Side AB is 2 times longer than side DE, because 5 times 2 gives you 10, so it's 2 times longer. Okay, we can also say that the perimeter of triangle ABC has a perimeter 10 plus 8 plus 6, okay, which is perimeter side plus side plus side. All right, so you got 18, and then you got 6, which is 24. Inches, centimeters, whatever you want to say, but it would be cubed because you have 3 sides. Squared would be only 2 sides. All right, so that's how you find the parameter, side plus side plus side, or if you have a square, side plus side plus side plus side, it's no different. All right, so we did the corresponding sides. Corresponding points. Point A and triangle ABC corresponds to point D and triangle DEF. Okay, let's give you another one. Point B and triangle ABC corresponds to point E and triangle DEF. All right, and your final one you should already know by now. Point C and triangle ABC corresponds to point F and triangle DEF. All right, corresponding angles. Your angles will stay the same. No matter if your triangle shrinks, your angles will stay the same, and they will be in the same corner, in the same angle, but on a different shape. Okay, this measures 46. This too will measure 46. If this measures 39, this too will measure 39. It's just that simple. Okay, pressing forward, that's your little degree symbol. Vocabulary, corresponding sides, corresponding points, corresponding angles. All right, let's move forward where we begin to speak in reference to ratios. Your vocabulary is area, which is length times width, unit rate, ratio, equivalent, your double line diagrams, which will make it easier for you to read equivalent ratios. Table, I want you to look up that term table so you can know where the rows are and where the columns are. And you also need to know proportional relationship and constant of proportionality, which we spoke in reference to the formula of the constant of proportionality is K equals Y per X. K equals Y per X. All right, either way it go, this sign, the dividend sign, means you divide. All right, so if K equals Y per X, Y equals K times X. If that's true, X equals K times Y. I put an arrow right here because this looked a little funky. So x equals k times y. All right. So let us draw us a table. Let's start like that first. And we don't have to be anything precise. We could use what we use. We could use rows of tissue and cases. All right. Always remember that I said in my class, you would always make this is the X column and this is the Y column. Start that first so you can know that all of these numbers speak in reference to Y variables and all of these numbers speak in reference to X variables. So again, up and down, which is vertical, will be columns. Side to side, which is horizontal, will be rows. So you have row 1, row 2, row 3, and row 4. All right. So for every one case, you get 12 rows of tissue. And I'm doing it backwards from my workbook. Okay. So for every one case times every one case, it gives you 12 rows of tissue. You got 2 cases, it gives you 24. You got 3 cases, it gives you 36. You got 4 cases, it gives you 48. Just that simple. All right. For every one, you multiply it by 12. Okay. Now, what we would say to find the scale factor, we've already discussed this in class. You go by rows. What was this number multiplied to give you that number? What was this number multiplied to give you that number? So the scale factor here in this table is equal to 2. All right. Now, setting this table up the proper way, because I did it backwards, we're finding the constant of proportionality. Okay. We're going to go ahead and we're going to put cases here, and we're going to put rows of tissue here. Remember, X, Y. I'm going to abbreviate row for time's sake. Row 1, row 2, row 3, row 4. Okay. K equals Y per X. All right. So 1 case, 2 cases, 3 cases, 4 cases. For every case, you have 12 rows. 2 cases, it gives you 24 rows. 3 cases, it'll give you 36 rows. And 4 cases, it'll give you 48 rows. Okay. So to find the constant of proportionality, which is K, you're asking yourself, in between these 2 sections, these 2 columns, what was multiplied by this to give you that? All right. So remember that these are Y values and these are X values. Let's just do row 4. Okay. So we're going to do row 4. K equals 48 over 4. Okay. And we get 12. So the constant of proportionality for this table is 12. Because again, just like we did the scale factors, what you do to one side, you have to, what you do to one side, you have to do to the same. So we had that one factor. All right. When moving from left to right, we had 1/2. Then when reversing it, we had 2. Okay. And all of those sides was multiplied by 2 or 1/2. Never will it be you multiply one triangle by 2 and then you multiply the other triangle by 1/2. Different situations. One situation you multiply by 2, the other situation you multiply by 1/2. Okay, so this is the same. Each row, the constant of proportionality is 12. So we could say the constant of proportionality for this entire table is 12. Okay, K equals Y over X. All right. Now, with ratios, say for example, you have a number 7 to 3. When you see this colon, that's how you read it. That's how you speak it. 7 to 3. All right. These are the X values. These are the Y values. Okay. So X to Y. All right. So and doing the situation again, K equals Y per X. If you set this up, K equals 3 over 7. All right. Now, don't think that this is something lining in your workbook, because this is not. These are different examples. All right. So now we're asking ourselves, I want you to find equivalent ratios for this number right here given. It's as simple as knowing your multiplication facts. What you do to this side, you have to do to this side. So to find an equivalent ratio, you can simply multiply that by 2 and then simply multiply that by that side. And you get 14 to 6. You can carry on. You do not have to. So say if I told you to find 3 equivalent ratios to 7 to 3. You can either multiply this by 2 and that by 2 again and get another one. And then once you get that answer, you multiply each of those by 2 and then get another one. Or you could do something as simple as you could use 3. All right? Times 3 times 3. Okay, so then you would have 42 to 18. All right? So this would be the first equivalent ratio. This is the second equivalent ratio. And then the third equivalent ratio, you could use 2 again. Okay? So times 2 times 2, you have 84 to 36. Just that simple. What makes these equivalent, they all share a relationship, and you can divide 2 by each one of these numbers. You have to know your least common factors and your greatest common factors. Take advantage of those opportunities that I gave you in Khan Academy and in Delta Math so you can freshen up your math skills. Okay, so find 3 equivalent ratios. Okay, those 3. All right, there's no specific order. Just as long as what you do to one with a factor, you have to do to the second with that same factor. So we started out with 2, we got to continue with 2. We started out with 3, we have to continue with 3. Okay? If you start out with 4, you have to continue with 4. Start out with 5, you got to continue with 5, so on and so forth. Okay? Also as well, let's pull these numbers out of this table. Now, just for the sake, I'm not going to write the title. I'm just going to write the rows. So you have row 1, row 2, row 3, and row 4. So just so you can see, row 1 was 112, 224, 336, 448. I'm going to say it properly once I get to the next page. So let's pull these out. This would equal, how you read this? 1 to 12. 1 case per every 12 rows. 2 cases gives you 24 rows. 3 cases gives you 36 rows. 4 cases give you 48 rows. X and Y. Don't forget that. Okay? Also as well, what else did I want to show you? All right, so with the constant of proportionality, K equals Y per X. K equals, just like I stated in class, once you have the formula, you can plug and play when you have the numbers. K equals 12 over 1. Okay. K equals 24 over 2. K equals 36 over 3. And K equals 48 over 4. All of them. The constant of proportionality for this table is 12. Okay, and what I'm going to start calling this is the COP, to abbreviate it, which will give you 12. Okay,